Hey everybody, I'm excited to talk about being able to express the electron configuration of any element that you want to on the periodic table. So what this is a summary of where the electrons can be found in nucleus. Um, you will never know where they exactly will be and their momentum at the same time. That goes against the Heisenberg principle. But anyways, so I'm going to show you how to fill up the sublevels and everything, all according to Aufbau principle. Anyways, so let's do some examples and so be able to give a summary of where the electrons, what sublevels they'll be in, and what energy levels they'll be in. So let's say they ask you about magnesium. Magnesium, the first thing you got to look at is the number of protons it has. As you can see, it has 12 protons. So we will write here that it has 12 protons, and then what we're going to do is we're going to make a table, and I'll show you what the table should look like. You have your s orbitals your s sublevels, your p sublevels, and your d sublevels, and your f sublevels. So you can see your s sublevels can hold 2 electrons, your p sublevels can hold 6, your d sublevels can hold 10, and your f sublevels can contain 14 electrons. So this is going to work for every single element on the periodic table except for chromium and copper. They are slightly different on the 4s and the 3d. So just bear that in mind. There's always an exception. So let's go back over here and let's go ahead and do the electron configuration for magnesium. So you write this table out. You see how the S, the 2p starts at 2, the 3d starts at 3, and the 4f starts at 4. So because it has 12 protons, it has 12 electrons to cancel them out. So we start off with 1s, and it's going to be 1s squared, or 1s2, and I'll put that 2 up later. So 1s, then we go 2s, that's 4 electrons, 2, 4. We got 2p, so I'll say 2p. Let's see here, 6, because there can be 6 and maximum in here, so 6 maximum, 2 maximum, 10, and 14. Sorry, my handwriting is terrible with this mouse. Anyway, so 2p6, 6. And that's 10, so we'll fill up this 3s orbital. 2. And so this is our electron configuration of magnesium. You can also look at the noble gas before it, and that's, in this case, it's neon. You can put it in brackets. You can say, okay, it has the configuration of neon, and then after that, so your neon is 18. Neon has 10, so you have your 10 here, and then you have 3s2, and bam. So there's a summary, there's like a shorthand version, but those are both ways of expressing the electron configuration of magnesium. So if we go ahead and let's do another example, we'll do arsenic. So you can see I already circled it because I tried to do this video before and had to redo it because I couldn't talk. But you have 33 protons, and so you're going to have 33 electrons. Okay? Well, actually, I'm going to undo until I can erase those little lines. Not that much. Anyways, that's okay. Alright. So, we have 33 electrons. So we start out 1s squared, 2s squared, 2p6, 3s squared, alright, so that's 10, 11, 12, 3p6, that's 18, 4s squared, 20, 3d, 10, so that's 30, 2, 4, 6. I'm going to quickly check my math. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10. It's 30. Four p to the 3, because there's 3 more electrons in there. Okay? So, yep. So this is our answer, our first answer, but remember you could also shorthand it. So argon, you say AR, you could say AR in brackets. And AR has 18, so we would count to 18 here. 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah. So 4s2, 3d10, and 4p3. So that will be our configuration for argon, for arsenic. Okay. So those are 2 examples. You can see how it works. If you need more, you can say, okay, 5s, 5p, 5d, and 5f. Just like in this diagram here. See how once you get to 4, it just goes down. F contains 14, D is 10, P is 6, and S is 1. That's how to do for the typical ground state electron configuration of each element. I'm not going to get into the ions just yet. I have to do a little research on that. But I hope this will help you if you're trying to figure this stuff out. Thanks.